Hey guys, when you get to this slide, we are going to have you actually use a simulation in just a minute to do an experiment. And this experiment is about whether light or dark colored clothing would be more comfortable to wear on a hot, sunny day. And what we're actually going to look at is how the color of different fabrics affect how much heat is absorbed. And so to get you ready for this, we need to actually set up your scientist notebook. So if you will go to a clean page in your scientist notebook, and at the top of the page, just write Nearpod hyphen controlled experiment. And then what I'm going to do is show you exactly how we want you to set your page up. And what you can do is actually pause this video as you need to make sure that you have everything set up in your notebook. All right. So after you title it that at the top, write number one, and I want you to write all these words that you see in blue because our experiment is going to start with a question. And I'll show you the simulation in just a minute. Right now, we just want to worry about getting your notebook page set up. So the question we're going to ask is, how does color affect heat absorption? And we're going to do that by looking specifically at some different colors of some jackets. And we're actually going to be looking at some different materials as well. But our focus will be on how does color, we're going to see if we can make a conclusion about how color affects how much heat is absorbed. So that's your question, and you'll write all of that out in blue. And then you're going to write number two, and you're going to write the word hypothesis. Now, I went ahead and gave you three different choices. So what I want you to do after you write the word hypothesis is you choose which one of these three that you think is going to happen. And remember, this is science. So if it turns out you're wrong, that's okay. That doesn't cause you to lose any points at all. This is just what you think might happen, and you will write that down. So here's your first choice. When exposed to the same amount of heat, lighter colored clothing will absorb more heat than darker colored clothing. If you think that's right, you'll write that one down. Here's your second choice. When exposed to the same amount of heat, darker colored clothing will absorb, this time it's darker colored clothing will absorb more heat than lighter colored clothing. And then your third choice is when exposed to the same amount of heat, both dark colored and light colored clothing will absorb the same amount of heat. So you just pick one of those, okay? Do you think lighter colored clothing will absorb more heat? Do you think darker colored clothing will absorb more heat? Or basically, do you think they're equal? So write one of these down. All right, for number three, we need you to actually draw this in and have it ready. Okay, draw this in. Write jacket color, black, blue, green, yellow, white. And you want to go ahead and write these words in. You'll be testing wool jackets. And I will be showing you in just a minute. I'll remind you how to get the average temperature, how you average some numbers together. You'll be testing some different colors of nylon jackets and some different colors of denim jackets. And you actually need to write the words average temperature in Celsius. So you're going to draw this whole table in, this data table, and have it ready to go. Remember, you can pause this video to make sure you have it in there. After we get a bunch of numbers in here in a few minutes when we do the experiment, we're going to want to take those numbers and turn it into a graph. So what I want you to do is write number 4, graph, and you're going to draw this graph in. So, and you've got to have everything ready to roll, guys. So go ahead, and these numbers go 22, 23, 24, 25, up to 32. This is your y-axis. You want to label it temperature in Celsius. This is your x-axis. You want to label it jacket color. And you want to go ahead and write in black, blue, green, yellow, and white. Now, what's going to happen, the computer simulation we're going to use in a minute does a very nice thing for you. It's actually going to make the graph for you. You will be doing the experiment, and I'll show you in a minute. You're going to be putting these numbers in. And then actually, after you put the numbers in the simulation, you're going to just click graph, and it's going to graph it for you. So you're going to end up with three lines on there. One line for the wool is going to be this kind of purpley pink color, and that'll be graphed out. The nylon is kind of a bluish color. That'll be on the graph. And then the denim is in green. So if you have those three different colors, either crayon, colored pencil, marker, some sort that you can do that, that's great. But let's say you're a kid and you're at home and you're like, I don't have any color pencils. That's okay. What you can do is just your wool. Maybe that can just be a solid line on the graph. Your nylon, maybe you could make little circle dots. Okay. And then maybe the denim could be like a dashed line. So you can just do a solid line, little circles, and then maybe dashes. Okay, just so we can tell the three lines apart. So you'll want to go ahead and you'll want to pause the video and get this drawn in. And then for number 5, we need an analysis and a conclusion. So after we've collected our data and we've graphed it so we can find the story from it, we should be ready to go back and answer this question. And our question was, how does color affect heat absorption? So in your notebook for number 5, I want you to write analysis and conclusion. And we've already done, and we'll be doing some work with claim, evidence, and reasoning all year long. And so in this case, just, our claim and our conclusion, we're kind of using those words to mean the same thing. So if this was our question and we've done the experiment, we should be ready to answer the question. How does color affect heat absorption? And so you will write one sentence right there to answer that question. Your evidence will be, ta-da, right here's your evidence, okay? Right here's the evidence, here and here. So you can cite your evidence from the data table and or the graph. And remember, the reasoning is where you want to try to put some science in there, okay? And so just thinking in terms of maybe what you know about what makes temperature go up. Obviously, that's heat, and the heat is being absorbed. Where's that heat coming from? Well, it's coming from the light bulb. In the particular case of the experiment, if you are outside on a sunny day, your heat is coming from sunlight. But your reasoning, try to put down why you think the evidence supports your claim. What do you think is the science behind what you saw? Okay. And this is the hard part. I get it. This is the hard part. You might have to think a little bit about exactly what is happening with light to make us be able to see certain colors. I'll give you a hint right there. We'll see if you can figure that out on your own. Here's another big hint. You might want to look up when we see something as black, what that really means as far as what light is doing versus when we look at an object that appears to be white and what that really means as far as what's happening with light. All right. Now, it's okay, guys. If your reasoning is not actually correct, that's okay. What I'm looking for here is that you're thinking. Okay. I'm looking for that you are thinking. Now, you should be able to get a correct claim. I mean, I definitely should see that you were able to look at what this information is, and based on this, you can answer this question. You should have a definite claim. You should be able to write your evidence. See if you can do your reasoning. This is the thing that most eighth graders are still struggling with, so we know that. All right, so this is how you're going to set up your scientist notebook. Remember, you can pause the video as you need to, make sure that's all set up, and then I'll have another video for you in just a second to help you make sure that you understand what to do with the simulation.